everyone, and welcome to another episode of Investigation. In today's episode of Investigation, I will go over the log with base of n of x. We've went over learn of x in the previous episodes, so that we are going to expand it into all of the bases, all of the, positive bases that we can think of, and we can use it more generally. As always, we will start with a daily problem. Pause the video if you want to try this problem, and proceed the video when you're done. So when we look at this problem, we see that clearly I've color-coded for you. There are two parts of the problem, and we need to use the power rule, or the product rule, my bad. And we can list a simple chart over here because this does look a bit complicated and it is kind of hard to just apply the power rule. So let's define the product function to be 2 to the 2 to the x, and the other product function to be learn of x. Then the derivative of this second function would be just 1 over x. And while we are here, I'm just going to mention this. Notice that learn of x has a domain restriction of x is greater to 0. So this also has a domain restriction, but generally we don't have to pay a lot of attention to it, but make sure that you don't make a mistake over here. And we need to differentiate this function now. This function, we need to use the chain rule and the exponent differentiation that we talked about yesterday. So that would be f prime of x. And what we have over here, let's give ourselves a bit more space, and that would be equal to the derivative with respect of 2 to the x of this thing. Should be relatively easy, and want to multiply it by the derivative with respect of x of 2 to the x. And this thing would just simply turn us into so we have this thing, so that would be learn of 2 as a multiplier, so like this, learn of 2 times this 2 to the x, doesn't change, and this part also learn of 2 times 2 to the x. Obviously we can combine that as learn of 2. Don't write it as like learn of 2 squared and then remove it and say it's learn of 4, because it isn't. It is learn of 2 squared. We can estimate learn of 2 to be about, let's say, 0.69-ish. This is not a joke. And that squared is definitely not equal to learn of 4. Because we know that learn of 4 is just equal to learn of 2 plus learn of 2, right? Not multiplied by. So now, that would just turn into 2 to the 2 to the x times 2 to the x. And we are almost done. We just have to apply the product rule on this, and this. So what we have over here would turn into I will just write the product rule straight up, and the product rule is just going to be this cross multiply 2 to the 2 to the x times 1 over x plus this thing, so this monstrosity kind of thing, that's learn of 2 squared times 2 to the 2 to the x times 2 to the x, and multiply it by learn of x. And technically this is our answer, and you can just simply leave it like this. But it is kind of messy, and you can try to clean it up a little bit over here, but you cannot do a whole lot because the learners are just multiplied together. You can't do anything about that. I mean, you can simplify this with the quotation mark to that, but I don't really see a reason that you would want to do this. This is just as messy, but it kind of looks a little bit cleaner. So now let's take a look at logarithm differentiation. We want to find the derivative with respect of x of this log with a random base a of x. And that would be equal to 1 over this, what we want. So we know that the derivative with respect of x of e to the x is just e to the x. And the derivative with respect of a to the x is equal to ln of a times e to the x. And the derivative with respect of x of this ln of x, this is equal to 1 over x. And using that, we can kind of guess what our answer for this is. This would be 1 over ln of a times x. But I will prove it rigorously. And we can use a similar thought when we derived this thing to derive our new rule over here. And this thing, we can break it up so we can use the change of base. That would be the derivative of this thing, which is what we want. And that, using the change of base inside the differentiation sign, that would be equal to ln of x over ln of a. So change it into the base e, because we know what we are dealing with when we are doing base e. And when we do that, because that ln a, it doesn't include x. It is just a constant multiple. You can think of this constant multiple as 1 over ln a times ln of x. And we can just get this constant multiple out using the constant multiple rule. So then we can just simply have 1 over ln of a times the derivative. So times the derivative of ln of x. Even if you see this thing, you don't need to use the quotient rule, and even if you do, you might get it wrong. Although it is possible technically, but you're just overdoing things that aren't necessary. And this, we just see, obviously we know that this is just 1 over ln a times 1 over x, and that is equal to 1 over ln a times x, which is exactly what we assumed over here. And it will be same. So if we look at this, if we look at, let's say, logarithm function like this, if you have a line crossing over, let's say, over here, let's say this, you'll see that this slope would exactly be this function. Thank you for watching this episode of Interstication, and this is the log a of x, and I will see you in the next one, where we start going over inverse derivatives. Goodbye.